The area of that triangle is this. We're given measurements of a triangle and we want to find the side length of AB. The first thing I'm going to do is draw a triangle and label it ABC. Dun, dun, dun. And angle B is 25. Well, that doesn't look like a 25-degree angle, but whatever. And BC is 7. We want to find the length of AB, so I'm going to put X there. And then it told us an area. So if it tells us an area, we should also write down the formula for the area, right? If it gives us the area, maybe we're going to be using that to solve for something else. And if we have a formula that brought us there, it's probably a piece in the formula that we're going to use to solve. And now we get to plug in the pieces that we have. Well, I've got an X and a 7, which can be my A and my B, and the 25-degree angle would be my C. So the thought process here, the way that we problem solve that is we draw a diagram to represent that information and then we don't have to think about it anymore. We labeled the thing that I want to find with a variable, or maybe you could put a question mark there or something, but if I want to find that, you should label it somewhere in your diagram. And then we had to take the information that we were given the area and put that down. And if we have a formula to find that thing, you should probably also write out that formula. Those are the things that are important for getting started on a problem. So just make sure that you're doing those things. You could use numerical solve in order to solve for this. Make sure to put comma X at the end. For those of you that don't remember what numerical solve is, TI-84's, I believe it's, oh, this is not my calculator. TI-84's, I believe you have math and then scroll up and its numerical solve is at the very, very bottom of that. For TI Inspires, we hit menu and then we go to algebra and then numerical solve and you type that all in. 29.6 equals 0.5 times x times 7 times sine of 25. I'm going to double check that I'm in degree mode. I'm going to make sure that I scroll out of the sign, but I'm still inside of the parentheses for the end solve, and then do comma x. So at the very, very end of the equation, this is my equation. At the very, very end, I do comma x and enter. It says just find the length, and I get, sorry, this is different than what my answer key says. It is approximately 20.0 centimeters for 3 sig figs. Okay, we're going to find the area of a parallelogram with that and that and that. So we're talking about A, B, C, D. I'm going to draw a diagram. Ba-bum, ba-bum, bum, bum. We'll label it A, B, C, D. None of my diagrams look correct, and I still understand the idea of it. Now this is where we start to get into like the IB type of stuff where we have all the tools in our tool belt, but we see a brand new problem. And a lot of times we feel like, oh, I don't really know what to do. And so if it talks about area of a parallelogram, you might have looked to your formula packet and you might have looked to see if you could find the area formula. And we don't have the area formula for a parallelogram, but we do have the area formula for a triangle. And maybe you're noticing, hey, this looks a lot like the information I'm given when I have the area of a triangle. Well, then we could say, well, isn't a parallelogram just two triangles? So then the area of the parallelogram is going to be equal to 2 times the area of the triangle. Write out that relationship however you'd like to write it out, but write out that, oh, okay, the parallelogram would just be 2 triangles. So then that way, your future self knows, oh, that's right, I'm going to find the area of the triangle. And once I have that, I'm going to multiply it by 2. Because a lot of times we get in the middle of a problem and we forget what we're doing and it wastes precious time. You can go ahead and calculate the area on your own. we calculate the area of the triangle to be about like 28.64037 yada yada, which means multiplying that by 2, we get about 57.3 centimeters squared. 3 sig figs. All right. More difficult problems here at the end. The roof is in the shape of an isosceles triangle, PRQ, where PQ equals RQ. Okay, I'll draw an isosceles triangle before I move on. And it's PQ and RQ. So PQ and RQ. I found out what they had in common to know that that would be that. And it says angle P is 61, PR is 12. And it says we need to find the area. So hopefully you all have realized the pattern here of things that we should be writing out at the top of a problem, a diagram, as well as the area formula. Okay, what do we have? We have the angle, boom, and we have one side length. But right now we need another side length in order to find the area. And so now we need to start thinking about how would I find another side length? Well, these guys are the same, so I could label them both X. And I could start maybe by filling out, I know it's a non-right triangle, so I have to use law of sines or law of cosines. And so maybe you think, okay, I'm going to set up law of cosines, and I get x squared equals 12 squared plus another x squared minus 2 times 12 times x times cosine of 61. And technically, that only has one input. Since both of these are x, because they're the same value, you could numerical solve, and this could give you the answer. Or you could try setting up law of sines, and you would get sine of 61 over x equals sine of, I don't know what these angles are, over 12. And so then we start to think, I don't know, maybe I don't know, or I don't have enough information. Remember that 61 with an isosceles triangle means that this is also 61. And then to know the angle opposite of 12, we would just subtract those guys from 180. So that's another relationship that you could find in this problem to kind of puzzle out the things that are underneath, right? So a lot of times you'll be given partial information about a triangle and finding ways, maybe getting to this point and saying, oh, okay, I'm stuck. I'm at a dead end because I don't know where to go next. This is where we start to look for like what else is there in the diagram. Subtracting from 180, we find out that this is 58 degrees. So I could actually use law of sines here to solve for x and put 58. And now I only have one input, so I could solve using this way. Go ahead and choose whichever way to solve, either numerical solve this or numerical solve that, and let me know what you get. We should get that x is approximately 12.37599 something, something, something. So 3 sig figs would be 12.4. And we are going to use that now in order to solve for the area, right? I had a moment of like, wait, what was I doing? Oh, right. I wrote down the area formula. I need to find the area. Okay, well, now I have all the information I need. I could either do this times the sine of 58, or I could do this times 12 times the sine of 61 divided by 2. It doesn't matter. They will all give you the same answer. I think because I have this number in my calculator already, I would just have to square it in order to talk about a times b, x times x. I would just have to square it, and then sine of 58. That's me just being lazy. That's it. Or efficient. All right, so we get approximately for the area 64.9 centimeters squared.